So, hello everyone. So we are live again. What are we doing today though? Are we live though? Is it working? Let's see if it is working. Okay, I don't see anything here. Okay, so hello I hope everyone. Everything is visible. So we are live again. Okay, what are we doing today? So all of you know what we were working on, what we started with, right? So today's goal to complete the research paper we started in the previous stream. Now there is where is the research paper we were working on? Hmm, just a second. I know this is wasting time, but to quickly go through this. There is so much. Yes. Fine. I have to go through all of my this earlier than this. Okay, here we are. Here somewhere. I guess this was it. No, it is not showing me the paper. Not be it then, right? It was clearly visible on the one we were working on. Uh, Data set. Okay. Yeah, this must be it, right? Yep. Yep, this was the paper we were working on. So today I'll not waste too much time into talking and going off topic. Today my goal is strictly to complete the work we have started. As you can see in the previous paper, you must be able to see it in the thumbnail. We created a basic classification model that is copied from this research paper, and we'll train this using the normal training technique, back propagation, conventional back propagation. So yeah, if anyone has a doubt, they can ask me. I'll try to answer it. I'll have the chat open right here. And yes, today we are completely focused on completing what we started, and we'll try not to close the stream before we get the test results for our training method and the conventional training method on this data set using this particular model we are having here. Okay, yeah. So now that's out of the way, that's clear. So let's get started. So this is what we have written till now. Let's get started. So first of all, I need to write a test test loss detector. So for the test loss, I will have to import the test data set. So we'll use this um, test directory. Uh, okay, that's weird. Okay, and instead of going into the train, we'll go to the test. Now I don't know. I think they have. Okay, wait. Let's do this. They have three data sets, but we just need the we need to test it. So I think what we should do is os.list dir test dir. Okay, okay, it is still connecting. We'll have to run these lines first. What is weird, my friend? What is weird? There is a lot of delay in the chat. I I don't know. I don't know. I'll look into how to reduce the latency. I'm not sure of it right now. So I already apologize if my chat and conversation doesn't make much sense. I will make it work from the next stream. Okay. So let's quickly go through these lines. We have already done this before. Will not waste too much time. Okay. Drive has been mounted. These were the assumptions. You have to pip install ONNX. Now we are just importing data set. These are the various transformations we are applying to it. We also have to look into the data augmentation and data. They are hyperparameters basically. What hyperparameters they have used in their paper so that we can use the same hyperparameters for our test case. Now let's see into it. Let's make a list of hyperparameters there. So let's have a markdown. Here we'll say hyperparameters used the research. Okay. So cool. So let's quickly go through them. The important ones being the batch size. So what are the important parameters that we need to find from the research paper? First of all, batch size is really important. Second of all, what data augmentations they have used. Third, the number of epochs. What laws they are using. So laws. And last of all, I think optimizer is also in some sense important, but I don't think we'll get any data around it. We'll just have to work with any optimizer. Most probably we'll work with Adam being the famous one. And the most Adam, in my experience, Adam seems to work the best for most of the cases, but we'll see into it. Lows, I assume they have used softmax for the final layer, so most probably they must be using negative log loss, or as you may know it, cross entropy loss. It's one and the same thing. So yeah, we'll be using that. Let's quickly see. Okay, so learning rate is also an important hyperparameter. Yeah. They have used decade learning rate. So here they have mentioned it. The model was optimized using mini batch stochastic gradient descent. So okay, so we get data on the optimizer tool. They have used SGD optimizer. And over the whole training data set with the following setting, a learning rate was initialized as 0.001 and decreased by 50% every 50 epochs. The momentum was set to 0.9 and the parameter of L2 weight decay was set to 0.005. Okay, so for optimizer, uh, momentum is 0.9, learning rate is 0.0001, 0.0001 or 0.001, 0.001. Every 50 epochs. What else information? L2 norm weight decay was set to 0.0005. I'm not sure about this one. I'll have to read a bit of the PyTorch documentation to see where we can set this from. L2 norm weight decay 0.00. These things doesn't really matter if you think about it. These are like they do matter. I'm not saying they are not important. I just mean that when you are working on a generic model, when you are trying to design a general algorithm for training a neural network, it doesn't make much sense to dwell into the fitting parts. Like these hyperparameters are basically used to fit our specific model to our specific problem and our specific data set, right? So it doesn't really make much sense to dwell into all of this uh, while you are trying to improve the overall uh, optimization techniques that are used, the overall training technique that is used. Okay, so yeah, so these are the training hyperparameters. Um, this all is not necessary. 10 experiments, we'll have to do it. We'll have to see the recurability of our experiments. So that is also important. Thus, we are not using sparse autoencoders. That is not necessary for the experiment we are trying to prove here. What else we can see? So, okay, so let's see the data augmentation techniques. Better generalization, we artificially increase the size of the data. We use 3 affine transformations. So this we have already done. We have when we were importing the images, we already converted them to 40x40. There must be the code for it. Yeah, as you can see, we resized them to 40, so that is already done. After that, we have rotated each image by 90, 180, and 270-degree counterclockwise respectively. Okay, so um, the where are the hyperparameters here? Data augmentation. For data augmentation, okay, why is it not working? Oh, this is markdown, right? Why is it not behaving like one? Do I have to use double tap? It works. Okay, it's fine. But are we wasting our time on? So yeah, rotation 90, 180, 270 counterclockwise. Counterclockwise doesn't even like you are doing 270 and 90, so whatever you do, they will compensate for each other. Now we have flipped each image from left to right and up and down respectively. So flipping. Down, right, like left to right or left, right to left, whatever. Doesn't really matter. Batch size. Let's look at the batch size. Yeah, this is all fine. We have a grayscale image too that already has been done. We have already normalized our images. So yeah, okay. So let's look into it. We have done this. After that, here are the other hyperparameters. Like there were some details in the graph as much as I can remember. So okay, so batch sizes. Okay, so there is the data. So which one gives better loss? Like error rate here is 0.62% and error rate here is 0.8%. So I guess 50 batch size was better for them, right? And after what? After 500 epochs using 1000 train samples and 800 test samples. What does how does it work? The comparison of classification error and the classification error versus batch size train samples. 1000 batch sizes are 1000. No, this there is in figure 7 to 8 the batch size is 15. Figure 9, can we even support a batch size of 200? Like we are using on a 8 GB GPU. We'll have to see. Maybe we'll have to. But 50 gives the better results, so that shouldn't be a problem. Now we are using 500 epochs. If we use 500 epochs, there is an error rate of this. And if we are using, I don't understand this table. Okay, the best results is bold font. Now I don't understand why they are Okay, let me explain what I'm confused about. So I guess it is not even that important. I guess it's fine. We can do same transformations on both train and test images, and it will produce the same result whatsoever. So that shouldn't matter really. It's fine. Okay. So batch size, we are using 50 batch size. So that's what's important. Batch size is 50. What details are left to find now? Number of epochs you are using 500. Right, that's the max they are going for. Okay. Loss. Okay, let's see. Yeah, they talked about linear units. I told you about it. Like using linear units literally means using no activation at all. I don't know how it worked for them, but it did, so that's great. Like it does make sense how it worked for them exactly. Like if they were using a fully connected neural network, it would not have worked obviously, because using a fully connected neural network without any activation would just mean that you are using a single layer that would not bring any change into the learning parameters. But using a convolutional neural net without any activation can work sometimes, because convolutional neural network doesn't necessarily merge the same way. Like if you use two dense layers without any activation, they will just merge with each other, they will just act like a single layer. But if you are using two convolutional neural network layers with each other, they will obviously not work the same way, right? Because you are literally reducing the dimensions of the image, you are taking out the data from a particular, like you know how CNN, I'm assuming you know how CNN works, so from that assumption you know what I mean. So let's not focus too much into it. So we just need to find the loss. I am assuming they have used cross entropy or negative log loss as it is called, but I just want to quickly get it away and just work on the actual coding part. Let's see. This softmax loss function is softmax regression, the overall loss function. Softmax regression. Now I'm pretty sure it is another name for, okay, what is softmax regression? Multinomial logistic regression is a generalization of logistic regression where we want to have multiple heads. Okay, softmax regression is the name for negative log loss. Hmm. Like I know how negative loss look, but is it the same as softmax? Like, see why I'm so sure about it. Let's see the formula for logistic regression, right? I know, I know it's not really common to see anyone live stream making a paper, but I just thought that while I'm working on this paper, it would be better if I could work with an audience, get the suggestions, explain everything I am doing. It would make it more clear in my head too. And while I'm doing it, I'm able to explain it, and I just love teaching. So there you go. That's why I am here. I just love to explain the things that are going on inside my head. And I think it is a pretty interesting research paper because, when we are working on this problem, right, we are basically working on how a neural network is trained. We are working on the very basics of neural networks, right? So I think if somebody is new to neural networks and is just learning deep learning or has learned deep learning through some extent, but just want to get more familiar with the intricacies of this, learning this paper or following these videos might to help them make better sense of it. So that's why I'm live streaming making this paper, and I hope it helps that ideal audience I have in mind. That's why I'm doing this, Clavis. Yeah. Okay, so let's continue with our research paper. Okay, so let's. So I was just showing you the formula for logistic regression, right? So there you go. So the formula for logistic regression is something like this, right? Now, okay, this is not the exact formula that would be able to help you, but yeah, see, this is where it will be visible, right? So you see, this is the sigmoid function, right? This is linear regression. You know, what is rate assignment? Cross entropy. Softmax to cross entropy loss. I don't understand this terminology at all. They have said they are using softmax regression loss. By the equation 7. Okay, let's quickly look at the equation. ln f of x. Okay, and what is phi? Have you explained what phi is somewhere? What is this? Okay, the model parameters are changed in the direction to reduce the weight of the loss function during the training process. So J is the loss, right? J is the loss and J is equal to 1 by n G. What is, why have they written this like this? ln of f of Frobenius norm. Okay, that just mean that is just similar to like you can Frobenius norm is just 2-degree norm and it's just second order norm and it just means, yeah, it's just similar to mean squared error. You can say that. This must be okay, so this is the regression term here. Oh, regression regularization term here. We are using a regularization on the weights. This is a L2 norm. So this was the weight decay they were talking about. Okay, so they are decaying the weight of the L2 normalization, L2 regularization uh, by some factor by 0.005, 0.0005. There it was. Right. I still don't understand the laws they are using. They shouldn't have taken this much. Uh, yes, I'll read this one just to make sure. You have to implement softmax regression in PyTorch. You can implement softmax regression using a PyTorch, a popular deep learning framework. We use the same Iris dataset in this example. Here is the laws defined, class softmax regression, and endot module, definite, super, softmax regression, linear, and endot linear, output dim. Thank you. I didn't know I was the only one that was doing it. I was somewhat inspired from George Hotz, by the way. He doesn't exactly write research papers there, but a lot of work that he did on Coma AI. You can search about him, George Hotz. A lot of work he did in Coma AI was done live on stream on Twitch, actually. And yeah, you can check that out, man. He's just amazing. He's on a whole other level. This is the Coma AI that I'm talking about. Just check it out in your free time. If you are into deep learning and stuff, you will really enjoy this. Like this is some thing to enjoy, really. Okay, so let's see what we have here. Softmax regression model. Okay. Like they implemented a single linear layer and then they are using cross entropy loss. That's what I was saying. I was just saying that use cross entropy loss. Like, why do. No, no, I'm not a first year engineering student though. I'm actually a fourth year engineering student. You are wrong there. Yeah. Okay. Let's just, yeah. So loss is just cross entropy loss. That took a lot of time. If they could have just clearly mentioned it, that would have saved us so much time. So instead of using cross entropy loss now, as we have used softmax into our like our model definition, we can simply use negative log loss. Now let me show it to you. NL loss and cross entropy loss in PyTorch. So basically, these are the so cross entropy loss is a function that combines two different um, two different steps in the same. So it takes the input, it applies softmax to them, and then it uses the negative log loss to use to evaluate our loss. And with the NLL loss does nothing. It just uses the softmax we have provided and uses. Yeah, there must be a good answer on this. Oh, okay, you were talking about yourself. Okay, great. I hope you learned something valuable from this stream. I hope you, yeah, actually drive some value from this. Let's see. So here there must be an answer. I read a very good answer on this. That's why I'm searching on these forums. Okay, so yeah, this answer also rather suggests me to know to use the soft max layer that we have used. Instead, we'll just use, yeah, so we are not using any final activation. We'll just call it an identity. Okay, and yeah, now this will work. So now our dataset has been called here. And this was just to test our dataset. How is it working? This was all written in the part one of this stream. After this, we defined our uh, classifier model. Now we have all the important hyperparameters from the data, from the research paper, I guess. So we don't need to dwell into it any further. Uh, yeah, let's just work with this. And yeah, so that works still. The model works. Let's test our model. So it prints a result, so it means it works without any error. Okay. For anyone watching the stream, always important to write code with tests. Otherwise, you will face problems in the long run. Now we'll import. So now let's come back to where we were starting from. All of the theoretical part has been done now. Let's just quickly see and let's just quickly write the code for getting the test loss. So this is the directory for our test data. Now we'll just call it in the similar fashion, right? We'll use the same transformations. Now let's quickly look into the data augmentation in PyTorch. I have done that before, but I am just not so sharp on the syntax. PyTorch. Image. Yeah, I know the benefits. Random horizontal flip. Yeah, we need that. Random rotation degree is equal to 15. Not color jitter. Not Gaussian blur. We need random horizontal flip. We need random. Okay, so let's call our data set one with this. Five. Five. Just expect degrees. Can't it take a list? Let's try it with a list. 90, 180, 70. Let's see if that works. Degrees should be a sequence of length 2. Use the random rotation transform. Could have used, but can't I give it a list? Let's see. Not sure if that augments the data though. Will it increase the size of the data, or will it just degrees? Sequence or number? Range of degrees to select from a degree is a number instead of sequence. The range will be minus degrees to plus degree. But we want number, right? We want three numbers. 90, 180. So instead of doing that, we'll have to write it on three lines. Now this works. Now I want to see the shape. How can we does it increase? Okay, it did increase it, right? Okay, that works. Those were all the things we needed to do. Now we have a data set of 1600 images. But should have been 16. No, it didn't. It didn't increase the data set. That's what I was talking about, right? This would just apply these random things to it, but it did not actually expand my data. How do I augment it to my data? That's the question, right? No, this is not it. Oh God. Why are these small things taking so much time? So annoying. I have heard about implementations before. I know it works great. Maybe I should use implementation. What implementations is a implementations will transform a.compose. What is the difference though? Does it add to our data? Many levels of data isn't. I'm trying to. I want it to increase my data set. This data set. uh, Data. But it is not increasing the size of data. What the hell? But train transform first was it's about 1,000 color images intensely defined. A data so data augmentation used in the Hmm, okay, I think we can work with it. Uh, I'm from mechanical engineering branch, really, but AI is something that I've loved and worked on a lot of time. I do love mechanical engineering too, though. I work on those aspects too. Maybe I'll stream it someday also. I will be shortly working in a research paper on mechanical engineering too. Let's see. We'll see how that goes. So now we have the augmented data, right? Now after applying the augmentations, now let's write the test classifier. So first of all, what is all of this? I've not written this. Oh, sorry. Oh, that what the hell am I? Okay, so this has been applied. I didn't apply any random crop though. I guess random rotation and random flips has caused all of this. But isn't it too much? We are rotating from 90. Why is it rotating so absurdly? I don't understand these weird patterns too. I don't know, this looks weird. Do something wrong. Maybe we should do this before any of that. That should have right. Before normalizing, you can even do this before even using grayscale or Two tensor should be the last one, I think. I don't know if it really matters though, but let's just for the sake of how everything is generally done, let's just do it like this. Let's import our dataset once again. Now it should look better. Looks the same. Images should be tensor got class PIL. Why did this not apply now? Okay, this is working. Yeah, okay, that's fine. Long as it works. Don't understand why the rotation has worked like this. It shouldn't have. The horizontally flip with the probability of 5, we have randomly flip vertically, rotate randomly 90 degrees. Randomly rotate from 90. This takes answer in degree, right? Random rotation. Even is such a weird way. You should rotate each image by 90, 180, and 2. Must be posing all of this real image. Still, if I remove these two rotations, it works. Can it be the normalization? I don't think. How have they normalized though? Once again, we have zero mean and unit variance in the whole data set. So we are also using zero mean and unit variance. That's what we did. Yeah, it's fine. I guess I understand what's happening now. So what it does, it doesn't just rotate by 90 degrees, it takes it as a range. So it rotates from anywhere between 0 to 90, as we can see in these images. So that's a problem. So how do I tell it to random range of degrees to select from? If degree is a number instead of sequence, the range of degrees will be minus to plus degrees. Exactly. See, so it's fine. We can use just 90. It works the same way as they have. Okay, now we define our model. After that, we test our model. After that, we have to import the test dataset and keep working on it. So we'll use the same transforms. So transform has been already defined. So we'll create a dataset. This time we'll call it test dataset. And so yeah, those remains the same. And other than that, we also use yeah, let's create a data loader. Here we'll call it test loader. Smaller batch size. not to make it too hectic for our system. And here we'll use it for I in range 10. We'll give it the model, the loss, and a test losses list, which, yeah, we'll give it that. For I in range 10, output is equal. Okay, one more thing that I had to quickly check. I had to quickly check that the dataset we are using in the test, I guess we have 16 images of each. That is very less. So I guess we have more images in the validation. Oh, they both have same images. So okay, let's do one thing. Let's combine these two datasets. Now, how do we combine datasets? So what we'll do is we don't even need to concatenate those datasets. I have a better way. What we'll do is it's a very simple technique, and I guess it just works because we are using it for testing. What we'll use the val dir, val, right, valid. What's with the big names? Now we'll create another for validation. Just in the same way. For random. So random dot choice test loader comma val loader. I guess it pretty much self-explanatory. So instead of using two datasets, we are randomly picking any dataset and using this for loop on it. So we go through all of the images in that dataset. Let's make the batch size 4. And what we do is calculate for I in range 3. Right. So what we do is output is equal to model images and we do total runs plus equal to 1 and loss, this loss, current loss equal to loss output label, total loss plus equal to current loss. At the end of this all, we'll return the loss divided by total. We don't even need this. I'll use that in the training loop. So why was I talking about a list anyway? So this should work now. We've just defined a function. Now let's define our losses. So loss we are gonna use is gross n dot loss on, and momentum we know. Can't we define momentum? No, momentum is a, so loss is this. Optimizer is n dot torch dot nn dot optim dot sgd. Right. It's might be wrong. Torch dot optim होता है, I guess. Torch dot nn dot optim. Yep, there we go. We find SGD. Here we define the momentum is equal to 0.9, and our learning rate we'll just quickly find all of the parameters. Learning rate, momentum, dampening, weight decay. Sorry. We also have to give it the model parameter. Yep, and quickly param. Let's see what weight decay does. L2 penalty. Yeah, we need L2 penalty. Weight decay is 0.0005. Right. Where have I written this? Okay. So here we say weight and how do I make the learning rate decay? I guess I'll have to manually define the optimizer each time. That works fine. Right. Okay. So we'll do that. What we'll do is we'll change the optimizer in the for loop as itself. We'll just LR is oh LR optimizer. in optim.param. Optim.param GLR is equal to A will do that. Mention is learning rate only depends. Okay, so we'll use this in our for loop after every epoch. Because after every epoch or after every 50 epoch, we'll divide it by 2. So yeah, that will work. So this is the lowest, this is the model. Yeah, this all should be working now. Don't need to initially define anything else. Right. So after that works, let's define a training group. So for let's give it epochs. For epoch in epochs, let's define the hyperparameters here. Or it's not necessary. I guess it's fine. We can hard code this one. For epoch in epochs, first of all, we take the output, which would be equal to model images. So for images, comma labels in data loader. And after that, we'll say our loss, current loss. Let's define it like criteria. That's the standard PyTorch code. Current loss. This should work just fine. I don't think we need to convert labels into anything. Let's just check the documentation just to make sure. Okay. So is there any use example? Okay, so here it is. Loss is equal to input comma target. The target is torch.empty 3 dot random 5. Torch.random 3 comma 5. Output dot backward. Okay. Why have they used softmax? We don't use softmax with cross entropy loss. Yeah, right. Cross entropy loss by torch. Let's see. So, so we have to now 0 comma 2 comma 64 torch dot random generate some random data 4 comma 10 0 comma 2 comma 64. That just means mean and variance, and this is the shape, right? 4 comma. Okay. Compute the Lowe's model criteria output. We define a linear model, 10 input features and 2 output classes. We also define the cross entropy laws using code. And next, we generate some random data consisting of elements in binary labels 0 and 1. And okay. For examples with 10 input features in binary labels. So this should work. Oh, but we'll have to one hot encode our data. We'll have to define a one hot encoder. Right, that's the maximum. There are 6. So 6 array tables. You can define a for loop here only. Well, in labels. A table. Dot append. Right. Now that this works, now we have a one hot encoder for our labels. So we'll use one for coded labels. That would be our loss. Then we'll go loss dot backward. Then we'll say optimizer dot step. That should be it. Right. I've forgot most of looked into this for a long time. I'm just trying to make sure I don't make any silly mistakes. That's the whole point. I don't want to keep going on coding and just find out that okay, I made a stupid mistake earlier. Yeah, I see. Optimizer dot zero grad. I completely forgot this. If I hadn't done that, that would have created chaos. It would just have resulted in so dumb results I would not have been able to comprehend it anyway. So it's good to keep testing your code when you're writing such a big test case, which you would not like to repeat over and over again. You don't want the whole loop to go through and then realize, okay, you made a silly mistake early on. Yep, these are all the steps. We'll also append our loss to our losses. Losses dot append. Right, losses. What's the point of even finding them? Okay, let me quickly right? And when we have done that, we'll also, after stepping through the optimizer, we'll, before stepping through the optimizer, actually, we'll also pull in the test loss, who will provide our model and our criteria, right? And this will return a loss. So, right. So this all should work. And let's also, if work equal to 0, print became learning rate and for G in optim.rm groups. Code, right? Right. Uh, is divide equal to 2. Is equal to, I don't know why I didn't feel safe with, yeah, now I feel safer. Right. Yeah, so this all should work. Let's also have it save our model into a directly. So when we have reached 50 epochs, we'll also have a saving condition. So okay, well in Python. This is the PT or PTH file exchange. Common Python PT. Let's just post.save. If load, here's the loading part. Model will be defined. Model dot load state dict. Model dot load get dict dot load. Now there is one more interesting we can do. We'll say not epoch. Let's write here. And if -1, -2, -3, -4. Excess. Don't make it too complicated though. I don't know if I really want to. Yeah, let's not go. Okay. Let's just hard code it for boy. Seems right. I don't want any of these complications afterwards. Let's make sure we're doing this right from the start. Way to convert to list vertences. I need the one with the capital T. One out encoder. आज जो हमारे पास आया उसको 2 डिवाइड करना है, राइट। Model dot loads dot ticked. Yeah, here I was writing the code for print. Okay. So what if I go the other way around? So this is what आंसर से लेके we go till minus दिया गया है। एक काम कर, do it this way first, but दिया है models. Just to keep everything clean. I think that's all the functionalities we need in our training loop. I think it's pretty much done now. We can delete this. Right, so this should work. This should work. Should work. What else was I changing? I made the device part ready now. Do we have the CUDA runtime? Don't tell me. Okay, good. We've defined this. We have defined this. Yeah, I have defined these. Now we have defined the training part too. Let's see if this works. Train model. Okay, let's hope for the best. For epoch in epochs. Wow. An early mistake, huh? That's good. Exists. While exists. Okay. If not in this dir, then yeah, now okay, something is going on. For just for testing purposes, let's just quickly make just to see. We should get one print statement, right? And one more thing. I've missed so much. Print. Okay. At the end, you have to return losses, comma, test losses. Rather than that, other than that, you have to also Anything else? Any important information that you might want to print? I don't think so. Let's go for it. I think everything makes sense now. You ready? And that would be enough. Sorry, yeah. Okay. Okay. I see. Yep, everything seems correct. So this is the code. You can look it up right now. You can read it a bit to see if I have received those first for the time being there. Oh, great. So now our model is getting trained, which is great, which is exactly what we wanted. And yeah, let's see how it's going. Did we print any result yet? Taking so actually, and it actually takes so much time. Doesn't make any sense. Everything is happening on GPU, right? Is the GPU getting used? 0.3, 0.4. Yeah, the GPU is getting used. Will it increase? Okay, that's weird. It's taking too much time. Okay, it's fine. You know what we should do by now? Uh, we have all of this saved, right? And it is getting trained. So let us get it trained. And other than that, we should quickly write, not wasting any time. We should save this, download this as an icon. Yeah, search paper. Yep, that's where it should go. And let's open another collab. Home another ID, obviously. Hmm, is this? I don't know. I don't know if I have enough storage. Do I have enough storage here? Yeah, I have good storage here. Let's upload our NU dataset. I am not sure if I have it saved. I must be. I haven't deleted it yet. Because I can remember. NEU dataset. Here you go. And let's upload our notebook here. So we still haven't printed any result. Are we sure it is working? How do I make it print some? I don't even know where it is. Can it be stuck in a loop or something? Should we wait even more? Model in os.list. Just haven't saved. Is the GPU getting used? Low, but yes. Okay. Okay, where are the resources now? How do I see the resources? Okay, there. That's what I'm happy with. Okay, this is weird. This is taking too much time. Shouldn't take so much. I'm pretty sure about the code I've written. Let's wait for a while. We have our code here now. Now what we want to do here is we need to define this in a different way, where rather than giving this, we'll also give a step. We'll have to define new dense layer. This is the final dense layer, dense 3. Other than that, we'll have to have a self dense 1, and self dense 2. Place them somewhere. So okay, so yeah. So after the second convolution layer and max pooling and activation, we have a 50 cross 7 cross 7 that would make it to be 49 into 7 into 7. 49 into 50. It was 2450. So we'll have 2450 elements here for the second one, right? 50 into 7 into 7 is for the second one. So we'll, for the dense 2, we'll write 2450 comma 6 as on the final layer, and for this one we'll write after activation it's left 20 into 18 into 20 into 20 to 18 into 18. That would give us 26480. So here we'll write, where is it again? 6480 comma 6. So what are we doing if it doesn't make any sense? So if any of you has seen my original making a research paper from scratch, you must be aware of what the research paper is all about. So the research paper is all about let me open it up quickly. Here you go. So as you might know, the research paper is all about training the neural net layer by layer instead of training all the layers in the single run. So how do we obtain that? So for doing that, as you can see in this image actually, if any of you have seen making a research paper from scratch, you would know that this image we also designed on the stream itself while explaining how the model actually works. So it's pretty amazing if you follow along this series from scratch. I know the videos are very long. You can skip many parts where I am just pondering my head over some errors or some reading stuff. But basically, yeah. So how the neural network, how the new training paradigm that we focused on works is we train layer by layer. Now how do we train a model layer by layer? So basically in a normal neural network, what happens is the initial layer send the layer output to the last layer, and the last layer uses a dense layer to learn from the loss function and then finally back propagate these errors. But instead of doing that, we employ multiple dense layers after each convolution layer, and we use these dense layers to sidetrack almost use a shortcut. As you can see, from the mth layer we shortcutted to this mth dense layer, and we used it to calculate the loss and then back propagated this loss to train this layer. So what happens is this layer is able to interact with the final loss uh, uh, with the difference of only one layer in between of it. So it gets a whole image of the final layer, and rather than a conventional neural network where the first image only gets to interpret the final loss function with the help of the inputs provided after passing through the gradients of the second layer. Now that's a lots of keywords, but I hope it makes sense to you. Now in this model, we'll use multiple dense layers, and once we train the first layer, we'll freeze that layer, and then we'll sabotage this dense layer that we trained. This is not necessary anymore, and we pass the outputs of the first layer directly to the inputs of the second layer, and then the second layer would use a second dense layer and use that shortcut and train that layer. After that layer is frozen, we pass to the third layer, and the same steps repeats and repeats. So that's why here when we are training in a layer wise fashion, okay, we encountered an error. Queued out of memory, tried to allocate 2 MB, 14.75 GB capacity, 14.4 GB already allocated, 832 KB free. Okay, so batch size too large. Let's reduce the batch size then. There is no other option. We can't do it. We need a larger GPU we're going to train. What do you think? In the research paper, they said they use a 4 GB GPU, right? How does that work? How does it not work for me? They used 50 batch size, right? Okay, we'll have to reduce the batch size. We don't have any other option. Where have we set the batch sizes? I think rather than doing that, we can do like this. No, but that would be great. Uh, this is just what is getting saved in the CUDA. Is there okay? So when we are training on PyTorch, we also need to take care of that. We shouldn't be saving too many things into CUDA, right? Otherwise, the CUDA would keep getting filled. So I think when we are sending these images to the device, they would not be deleted from the device, from the CUDA device. So you should move them back after use. Let's try to do that. And also we'll have to use the encoder here. Device here, but instead let's try this. Hope this works. Start from beginning. Oh, it just crashed. No, that's bad. Crashed RGB. What did we do wrong? Now we'll have to train on the CPU. Let's hope we can get enough speed out of it. Otherwise, we'll have to wait too long. Not make you wait though. Man, this is just an just crash. Now we can't even do anything about it. Just we have used up all the resources. And I just remembered we are not even used. We have not even correctly get the batch sizes here. Should have been implemented in the data loader. Oh, no, this is a big issue. This happens with PyTorch a lot of time. Batch size getting reducing batch size. There is one more thing, right? We are not. I hope we are not doing any silly mistake. Source the tutor.m. That is one way. God, I should not have happened. No, our model is small. Batch size is. We are not applying data documentation. Finally, anything you can goes can happen if you're not really. So I delete images every time I do that. I'll have to. This is risky. This is. I'll have to do it. I don't want to kill this one. Hmm. Okay. I don't want to kill this. It's just not working. Hmm. कन्वेंशनल टेस्ट तो हो जाए. Oh god. Yeah. Teacher. We'll use oh no valid file for the classes. Uh, wow. The exact same file structure. Okay, it gave an error here too. Then it's good. Then there must be a mistake. Okay, it is still uploading. That's why. Let's wait. But we are getting no results from this. The RAM is also getting pretty worked up now. This runtime will just crash. There is no way to save it now. I'll have to fix this somehow. I don't know how. I'll have to fix this. This is not working. No, this is not training. This is just gonna crash any minute now. All the resources are being used up. Is anyone here aware of how to do this? I'm still in my learning phase, guys. Need to make it work somehow. Must have done something wrong. I think I'm accumulating some unnecessary things, but I don't know what. I'm not even. Okay. I think maybe I'm use, accumulating the losses too often. Can that be a thing? The working memory, right? Okay, let's not do it then. Let's not do it this frequency. Yeah. For current percentage equal to 0. Very sure there will be 20 epochs. Good 5. This is the only way the RAM can be getting work. तो पक्के से हाँ यार, that is definitely. This one is not right. Been uploaded yet? And this is just gonna crash. What is happening? There shouldn't have been any error in the conventional training step, and now we have. Well, that's life, I guess. That's life. We are getting an error for such a stupid thing. I don't understand what's even happening. Okay, can you just quickly upload this? Oh god, we shouldn't have been getting an error for that. Okay, we'll have to look at the background, then I'll have to do work. I can't do anything else about it. We have written most of the code here, so I'll not be able to show code for step-wise training till this training completes. I'll have to make sure that this model works, then only I can change the model so that it trains in a layer by layer fashion. So yeah, I think if this doesn't work by this simple solution, let's get let's wait for it to get uploaded, then we'll quickly delete the images, and after use we have also changed the frequency for them getting saved. Let's increase it even more, I guess. Let's do it like that. Good. It just only runs. That shouldn't be a problem. Be a problem in terms of time complexity. This runs in a long time. At least one epoch should be completed before that even happening. So instead of doing that, you know what we should do? We should save our losses at each epoch. Yeah, okay. Instead of saving every time, yeah, now we are saving it at every epoch. That's the best, right? Like that's how slow it gets. No way to get it slower than that. I mean, like, yeah, we are reducing the memory intensiveness by a lot by doing this. And after using an image here, we'll delete images. After using the which labels, because you have to device which tell which labels. Yeah. We are clearing the GPU now, and let's for starting every epoch, set torch.cuda.mp cache. There you go, Google. Catching up, huh? So now we have all the files uploaded. So now the error should not be there. Hell, it's the exact same thing. Are you kidding me? What? Index 16 is out of bounds for dimension 0 with size 16. We hate this. Oh, it must be because of the bad size. Okay, there's no need to be angry every time. Yes. My God, I'm so scared. Please don't give me. Let's apply TQDM here, maybe. Let's import TQDM so that we know something is going on. TQDM. TQDM is basically a library that helps us to keep a count on the, like, it helps us keep a count on. Oh my God, what am I even saying? Let's just. Okay. Please work this time. She, not even one iteration is completed. Even this step has not been completed yet. Like this single step. This single step. I don't know what's happening. I have no idea. The GPU getting used up? Not much right now, but it'll increase. Right? That's what happens. What happened the previous time? It just expunged. It just blasted. Why is it working? Oh my god, am I being stupid? Is this me being stupid? No, but no, not. Batch size is 16. Yeah, everything is. Should I drop it because I didn't do drop there? It's shown an error on the shape of the not begin weird result. There. No, 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 no. Crash the GPU. Okay, what can be the mistake? What does test close to? Again. For images in there are very few images. Try to do it. Not that I think it will. Goofy thing. Also need to take much. This should also take. What is taking so much time? Nothing should be taking so much time. What is this? Okay, it's fine. That's fine. Don't even need this. That's how you do that. Test loss is also correct. Optimize the third zero cross, zero grad, loss dot backward, optimize the dot step. That's how you do it. Anything wrong with it? I don't know. And this. And I'm just seeing error in the silly things. Is it even working? Can't. That might actually be the mistake then. Okay, that was actually the mistake. What the hell is that? That's so stupid. Oh my god. I would have been literally here all night just worrying what it was, and it was just a naming convention mistake. Guys, my god. This is such an important learning now. This is such an important learning now. Never name the local and global variables the same thing. It causes chaos. My god, it caused absolute chaos. What the hell, man? I would have literally been writing code for the stepwise training, layer by layer training right now, and I had to. It just literally crashed one of my GPUs, like Google Colab GPUs, but I'll not be able to use it today now, na? So it's just wow. Okay, great, great. I guess we should be happy with what we have now. It is at least working. What? There is some ITQDM, right? For IT. Yeah, you see, these are the things you learn with experience. Now it will work great. Unmatched? Don't scare me. Please, I've had enough for today. Now, is it working? Is it looking good? Great. One epoch will take how much minutes? Just 5 minutes. Just 3.5 minutes. Okay, wow, you're fluctuating a lot. I'm not talking. I'm not talking anymore. I'm sorry. So, we have to go to 500 epochs like these. Yeah, that's a bit of long time. Let's try to increase the batch size now, though, as we had to increase the batch size anyways. It was just that we were trying if it is even working or not. So let's quickly increase the batch size now. Let's make it 50. Should be able to handle it. And other than that, we also change our test. Let's make our test more reliable. Man, but this naming issue. Oh my god. I am still not over it. I'm really not over it. What the hell was that? Just having to go through all of that. Maybe it will help me use the GPU more efficiently too, as I'm using these delete statements now. So I think it should be in our benefit. But man, that was just chaotic. What the hell? Why don't I see a TKDM here? What's happening? I remove that. Why would I remove that? I have that. I'd rather have that. Nice. Yeah. Now we have 34 of these because we have a batch size of 50. So let's see how much minutes it will take. batch size. For one epoch, you have to go through 500 such epochs. I just hope Google Colab doesn't ditch on us. I hope we don't use the resources too. Uh, yeah, we need to even. Yeah, we need to take care of that. We'll return closes, test closes. Okay. I need to store these, man. Here now. At least they'll be getting printed, right? So I think. Let's see. It was taking 5 minutes for that. So it should take around. It should not take more than 6 to 7 minutes for this. So if it takes 6 to 7 minutes, 7 minutes, that would mean 360, 360 divided by 34. Would have took around 10 seconds for each white stick. Is it not working again? Should I do something about it? I think I should have keep the batch size small then. Oh no, it's just when I clicked it. Just when I clicked it. I think it takes more time through the initial phases. Just when I clicked it, right? Or was it supposed to be like that? I don't know. Let's just wait for a while here. It's fine. We have more IDs. We can use more collabs. It should just train. That's the main objective. Okay. Before going to that, at least one iteration should happen successfully before we go anywhere. I hope I have limited resources. I have already used 1 GB GPU. Already used 1 GB GPU. Man, 500 iterations look tough now. Around 41 minutes. Still training on CUDA, right? That sucks. Okay. Yeah, as I was saying, the initial one takes longer time. So it should take around 10 minutes per iteration then. That's what my guess is. 10 minutes per epoch. That still accounts for a lot of time. Okay, it's finally getting trained real quickly. Let's see the losses. We have to also make sure the losses are getting reduced. Wow, I'm just, man, this naming error was just something to look at. Wow, that just made me crazy. That made me so angry. It was ridiculous. But it's cool. Everything is cool now. We are finally getting our model to train. Let's hope for the best. And the conventional, I'm not even worried that much about the conventional case. So, okay, it's showing 9 minutes now. 2 minutes have already passed, out of which. So, I think it will take around 10 minutes as we assumed, right? So, it will 10 for every epoch. There will be 500 epochs. Do we have data for lesser epochs? we should train till 100 epochs. Yeah, I don't think. No, the model will be sold anyway, right? We'll have the losses anyway as they are getting trained for every epoch. So even if we train for 100 epochs, they have the 100 losses printed out for us. So what's the point? On, that there's no point in stopping the iteration now. We'll just be wasting the resources we have already used. Wow, we are really ramping up on resources. That's bad. That's actually bad. Sorry, well, I'm just checking on a few things. Just give me 1 minute, and then we'll write the code for our stepwise training. Like that's the highlight, right? That's what we are contributing. Other than that, this is just conventional training. This is how you conventionally train a neural network for classification. We have you copied the neural network from this paper. We have copied all the hyperparameters from the paper too. So this is a good exercise. Like when you go in a field like um, this, like deep learning and artificial intelligence, if you are interested in a field like this field is very much in the frontier of science right now, according to me. And when you are talking about these fields, it is really important that you are capable of reading a research paper, going through it, able to understand it, and it would be best if you were able to mimic it. Now, I'm myself not capable of mimicking the advanced neural network papers that are out there. They are doing such an amazing job, and so much math, so much brain goes behind every single line of code written in those papers. But just this simple exercise, right? We didn't thought of any model from our heart. We use their model, we use their hyperparameters, we extracted that information, we found their data set, we use their data augmentation. So this forces you to learn new things, right? So it's always good to force yourself in learning new things. So that's why I think, especially in fields like neural networks, uh, not just neural networks, I mean artificial intelligence, I think it is really important for oneself to be able to read research papers and read in general. Like so much content, so many books are published each day when we talk about AI, and they are just amazing. You go through them, you'll get so much understanding about AI. There's so much amazing stuff to explore right there. Like I was recently, okay, let's go through a short video. Let's, while the model is getting trained, let's go through some of the books you should read if you are just entering AI or you're already in AI. Now, these are not all the beginner friendly books I'll be recommending here, but these suggestions are in general for anyone in the field of AI. So, when I started learning deep learning, the first book that I came across and went through was this by Francis Lloyd. I must be mistaken on the spelling for sure. Yes, yeah, I was way off. But this book, amazing. Go through it. It will go through a task of image based data, then a text based data, then generative AI. It also talks about GANs. So definitely one of the first book I read, and it is just amazing. If you are looking into the ML side of things, approaching almost any machine learning problem. Now, this book is popularly considered as a Kaggle specialty. Like if you are into Kaggle, you should read this. But I suggest this book for anyone. Like I directly came across the PDF. You will also be able to find the PDF easily then. Like it goes through the various techniques that are used in machine learning. It basically is like a hands-on book. It tells you how to solve problems when it comes to machine learning and how machine learning is actually used when it comes to different competitions, real life problems as such on Kaggle, and how you can go through them. So you will learn how you can approach image segmentation, classification tasks, text segmentation, classification class, image ensembling, stacking, reproducible code, model serving, feature selection, feature engineering, all of the skills that are necessary for a machine learning engineer. And one more thing, one more book that I'll recommend to any machine learning uh, person would be, I'm not exactly, it was a Manning publication book. I read a lot of Manning publication books. Their books, la, Croaking Machine Learning. I've read this book. This book is amazing. This book will teach you with so much illustrations. You will not feel you are learning such a theoretical concept. It will make it all flow. Go for it. Like these are the recommendations. And now, if you are on a bit advanced level and you're trying to uh, explore different endeavors available in machine learning and deep learning, and you want to make something that is in the frontier of the field right now, then I'll say evolutionary deep learning. Again, Manning publications. I literally, man, Manning publications best. I really love their books. I've read many books published by Manning publications, and they are just amazing. This book, I read a few chapters of it. I've not completed it as a whole, but this book is really a good book. Like you must have heard about the Azure platform by Microsoft, and also SageMaker by Amazon, I guess, also works on the same thing. Like the automated deep learning platforms that use evolutionary algorithms, genetic algorithms, and combine them with neural networks to make the whole process of even designing the neural network automated. So for a problem, we don't even need to design the neural network. This level of automation you are getting at. So this is definitely a field that is going to grow in the future, and combining these two aspects of learning, genetic algorithm has proved way amazing in terms of gameplay and stuff. You must have seen videos on YouTube like uh, genetic algorithm playing games. There are multiple. You see, this is also my search. It's amazing to see how well genetic algorithms do in gaming, even when compared to reinforcement learning. Like, not in terms of complex games like chess and Go, but in terms of simple games like Mario and stuff, genetic algorithm can work really amazing with really less computational resources. So you should definitely check it out. Other than that, I'll also recommend a book, Deep Learning in Production. Now, this is someone for someone who is looking into DevOps. Where is it? Yeah, by AI Summer. This book is some for someone who is looking into DevOps. Now, this book basically teaches you how to make production ready, deployment ready machine learning and deep learning models, and definitely one of the recommended books. So these are few of the book recommendations from me. Deep learning with PyTorch. You can start with this. Really basic, really good to go with. Approaching any almost any machine learning problem by a Kaggle Grandmaster. Mostly focused on problem solving, but really opens up your brain on how deep learning actually works and why some of the topics you learn in deep learning are so necessary to go through, because how much they can ease your problem solving and improve your solutions. So definitely you should read this. If you are just starting out with machine learning, Grokking Machine Learning, I would say you should read Grokking Machine Learning first, and after that you should read Approaching Almost Any Machine Learning Problem. If you are just starting with machine learning, as this book goes through a lot of illustrations to explain you machine learning, and you will get a basic instinct for it. Literally, you will get an instinct for it. Other than that, if you're advanced in the field and you're looking for different endeavors to explore, evolutionary deep learning, definitely combining genetic algorithms with neural networks, very interesting field, a very new trend. You can see it in Azure platforms for Microsoft and the Amazon SageMaker platforms and stuff. Now, deep learning in production for someone looking into DevOps. And there are lots of fields to explore in this after all. Like, I am so much interested in reinforcement learning right now. I'm doing multiple courses in it, and I've read many books regarding reinforcement learning. That is one of the skills I have not learned enough yet, and I feel intimidated by it somehow. Like how much maths is involved in reinforcement learning and how much ahead it is when compared to the other AI technologies we have. But definitely, if you are looking into reinforcement learning, go for it. Go for various courses available. You will have to go through the theory first. Now, Rich Sutton is considered to be the uh, like Bible of reinforcement learning. Uh, reinforcement learning. This is the Bible. Now, this book is all sometimes too mathematically complex and too plain. Like there are not much analogies you will find. There are not much like illustrations you will find here. So this might feel boring to you. So there was recently a course I was doing by DeepMind. DeepMind has some amazing research. Uh, just if I can mention that DeepMind has an amazing research in terms of reinforcement learning. So this is the course provided by their own staff. Definitely, this course makes it much more interesting and much more involved. So go through it. That's all the recommendations I have. So let's see how our training is going. So okay, the epoch ran successfully. We have a loss of 1.7 to 64 decaying learning rate. Did I not? Oh, okay, 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 okay. That should not have happened. Oh my god. I have to literally do it because of that. Oh my god. I hate this. But now we know the training is working. So let this train. The code is working properly. So now we can use this code to write our layer wise training code, right? So let's go for it. Let's work on that now. Okay. So these are the recommendations. Once again, I'm just quickly scrolling through them. You can look at them in your time. Let's close this tab now. Okay. Bear word me now. Okay, this is getting trained. It looks faster to me somehow. I don't know why that might be, but okay, fine by me, be faster. But yeah, we have we don't have much GPU resources in our hand. I'm not even sure if we'll be able to complete 15. A lot of GPU. Let's see. Let's hope for the best. At least if we'll have a working code now, we can train it in the background. I'll train it for you. I'll keep the results ready, and uh, I'll not do anything with the results. I'll not hamper the results. I'll just have the plain results. Most probably I'm gonna make graphs from it anyway. Like I'm gonna use this test loss and loss to make graphs of it, and I'll store those graphs. I'll store these loss values, the final loss that we were able to achieve after different epochs, just like they have, right, for 500 in these breakups only. And yeah, so I'll have that stored. And yeah, so that's what I would be doing with this experiment. And other than that, now let's write our code for the stepwise training. Okay, that's the next step. So let's open yet another collab. Benefit of having so many IDs. It's almost like a cheat code. But when you're lacking on resources, you need to do stuff. Not file upload. Let's download this one. Just replace it with the. Yeah, replace it. Cool. Let's upload this for notebook. Um, here we go. We're finally here. Now let's quickly change our code. So we'll have to introduce a step here that we'll have to input. Other than that, we'll have to introduce extra dense layers. And what will happen is if step equal to 0 or if step is equal to 1, we'll just pass all of these and we'll do this. Right. Okay, now that's smartest way to write it. Instead, after all of this has happened, if step is equal to 1, so we'll exit the loop here by using this. Hence 1 x. We are not using any activation anyway, but let's just do that for the coding point of view. If we decide to change that later, we should have the option to, and we'll return x. Straightforward. If we use step is equal to 2, we'll do all of this again. Just instead, we'll be using dense layer 2. All of the other things remain the same. And if we are, and this is just the else, right? Nothing, we'll just run that. So if step is anything except 1 and 2, we'll just do that. So does this make sense? This makes sense, right? So when we'll train initially, we also need to freeze this. Okay, you also need to freeze these. So how would we freeze these? So we'll only reach here when we go through all of this. So once we have gone through all of this, can't we say no? We'll do it otherwise. Do it in the code. Uh, no. How to set to non-trainable? Okay. So what I need to do is working right. Okay, this one is working. Oh, whole is so scary now. Okay, so where was? Give me a second. Why? Wait, what? Ah, let's think about this. So this one is working. These are our losses. Somehow the training loss is greater than the. That's not a good sign. But it's just epoch 0, so sure. Let's wait for one more epoch. Hmm. So we need to freeze the weights, right? So does it have a attribute like this? पता लगेगा. I don't think. Oh, else. I've done all of this before. Why have I forgot this so quickly? There we go. How did I freeze the layer? Yeah, this is correct. This is correct. But how did I freeze them? Hmm. So layer in model con one dot parameters, comma dense dot parameters. So I froze them here. What if I froze them there? It's and how I've done that. This will remain the same. And this. The file's been uploaded yet? Oh wow. Really. Okay, so we'll not be able to test this one. How are we doing here? We're using decent amount of GPU and not using too much. I think we'll be able to get through some iterations and make sure at least the loss is getting reduced or whatnot. That's also a thing we need to take care of. The loss must be getting reduced. Otherwise, we'll have to face even more errors. But we'll work through them. That's what we will have to do. No other option. Just fine. Let it upload. Okay, there is an BMP bitmap pixel bitmaps upload. Get it how I've done this earlier. There must be a better way, must be a cleaner way. So what if I do it like step is equal to 1? So this will happen. But if step is equal to 2, then तो तेरे कोड में भी होगा ना. तेरे फर्स्ट कोड में भी. So this is what the basic code should look like. And the problem we are facing is with this data set right now, it has not been updated yet. Um, So I think there is no point in delaying the stream right now. It's training well. Only the GPU is being an issue right now. I don't know. I'll let it train. So we can see the loss is getting reduced, and obviously the training loss is getting reduced faster than the test loss. So it is training in the right manner. So we have got the training condition right here. So I'll let this train. I'll let it happen. And other than that, as you can see, we have written the code for the layer wise training function already. We will not be able to test it right now because of the dataset uploading is taking too much time, and I don't know if there is any point in waiting any longer. So I think I'll let it train and test the code. I'll let you know the changes I made to the code if I have to make any when I'll test this on the dataset. Uh, I'll let it know in the next stream. And in the next stream, majorly we'll be discussing all the experimental results we'll get that I'll be working on in the background. You'll not have to worry about it anymore. So, okay, in this stream, we wrote all this code. I hope this made sense to you. We started from here, and all of this was written by us. I hope this made sense. We faced some errors with the naming convention and stuff, so it is a important lesson here, I guess. You should not name the local variables the same as the global ones. Now, it is obvious, but mostly you do that and it works in casual programming. But I guess with PyTorch, this caused a major problem, and we were not, we wasted a lot of GPU resources, and one of our models, in fact, crashed one of our collab GPU. So it's not good. Take care of that the next time you train a model for yourself, and it's taking around 8.5 minutes for each of the epochs. So for 500 epochs it will take 8.5 into 16. Those are the number of seconds, those are the number of minutes, those are the number of hours. Those are the number of days. Oh wow, those are a lot of days for training. I don't have that much time. We'll see how much we'll train it. I'll have to use another GPU, I guess. This will not work. Collab will not work for this. I'll have to arrange some GPU for training. So, okay, I'll do that. I'll let you know the results. I'll get the results as quickly as possible. I hope this code made sense. The stepwise training code. This is the only thing that we have introduced. Like that was just conventional training. I hope this helped you understand a lot of code, though we wrote everything from scratch, and I tried to explain everything as much as possible. And yeah, so this is the code for the stepwise training, right? So when we reach step 1, we exit the code, as we have to only train to the first layer, and we use our newly introduced dense layer, so that we can get the output dimensions to be the same as the loss that we are expecting. And if the step is not equal to 1, then we'll go to the second layer, and we'll also have to at the same time freeze the weights of the first layer. So what we should do is actually, yeah, the weights will be freezed. I think it is better to freeze the weights in the training loop itself. I think I got it right the previous time. So we'll do that when we'll make the training loop. I'll let you know the code changes. I'll make the code changes offline, not on live stream. As you can see, a lot of time would be wasted if I wait for this. Then this is also happening. Maybe I should wait for this. Um, I can write the code right here. It's not a big deal. So yeah, so as I was explaining, so the it goes to, if it has to exit the first layer, if it is the first step in training, then we only train the first layer and exit the whole forward pass. We don't go through the second and third layer, and this is how it works. If the step is 2, then we ignore this. We go through the first layer, then we go through the second layer, and we exit through the second layer again by flattening the x and then exiting through the dense layer. The dense 2 works in the same way and gives us an output of 6, which is our expected output size. And yeah, and returns it and exits the loop here. Now if the step is neither 1 nor 2, so we have to go and train the whole loop. So that means we can just directly go through the first layer, then the second layer, and all of these codes will be ignored, and we'll finally get the activation in a conventional way. But the only unconventional thing that will be happening there is that when we'll be applying the training loop, uh, during that we'll use this code, right, where we'll tell what we want to stop from training. So these will be the major aspects, because after the step has increased, now here I must have used zero indexing. So right, it starts from zero. So that's why it works this way. Here we have used first index, so we'll say if the step is greater than one, then freeze the weights of the first layer. If step is greater than two, freeze the weights of the second layer too. So now this will be also be frozen, these will also be frozen. And after that, we'll train the model. Let's just, you know what, we have already written the steps, right? So let's just quickly write this too. So instead of uh, training like this, we'll train for half the epochs first of all, as we'll be going through, not even half, we'll say 500 by 3, not by 3, divide by 3, otherwise there will be some difficulties. Now for I step in range 1 to 4, right, because we are using one indexing for steps, let the return be there only. Rest everything remains the same. There is not much change to the code. That's the best part. So all of this remains the same. This remains the same. Only thing that changes is while output, we also input step. Before any of this, we also say similar to this code. Let's just copy this. Step is greater than 1. Step is greater than 2. Step is greater than 1. We'll freeze the layers. Cone 1. Oh wow. Coincidentally, the names are also the same. Right. Cone 1, cone dense 1. After that, we'll freeze the cone 2 and dense 2. Right. That makes sense. So if the step will be 2, we'll freeze the weights of the first layer, and steps will be 3, we'll freeze the weights of the first and the second layer. So after that, all of this remains the same. We'll just pass in step there. Step will work the same way as we expect it to. Here, if step is equal to 1, it will exit from there. Step is equal to 2, it will exit from there. Step is equal to 3, it will train the last layer. Right. And everything should work. Is it uploaded? Upload complete, just one field. Retry that one. Okay, great. Now the upload has finished. Let's just do it anyway. Okay, great. Hmm. It should work like this. There shouldn't be any changes to the code, any more changes to the code other than what we have made. Let's just see. Wow, taking a lot of time. Fine, it does that. Have we changed the batch size though? Okay, great. Okay, yeah. The test would also change for I in step. तेरी याद तेरा और मेरा this should work now. Yep, we get all the 3 outputs, so it's working for all of them. You can print that too. It makes it more compact. We'll say by default the step is equal to 3. That's something we need to do so that our model works fine. Otherwise, it works. It's fine. Nothing to worry about here. This works. Test flows changes. You also have to pass the step 2, and we'll pass that step to our model. Okay. This should work like that. And I'll remove this from the same. Wait. One item encoder must remain same. This should remain same. Now here pass in step. We'll also pass in step creating the test flows. Let's see if it is working or not. Should be faster though. Should be faster than our previous training algorithm. So let's see. It takes time for the first iteration, so it's fine. It doesn't mean it's slower. We'll get to know quickly. Let's see if it is working or not. It 500 divide by 3. So the whole point of my algorithm is, and why am I only using dividing it by 3 the epochs? I want to prove that it takes less training time. Now, if I have to go through more epochs, it will take more training time. So what I say is, like, this method is actually able to bear higher learning rates because it doesn't overfit to the data so easily. So what that allows us is that we can train it each layer for lesser epochs and it will reach the same optimum value. That's what we are promising. So by reducing the epochs, but instead training the layers individually, we'll be able to achieve the same effect, and we'll be able to reach the same level of accuracy or even higher level of accuracies than the conventional model by using less resources and using what we call less time. The losses are reducing. It's fine. This much fluctuation happens. It's not problematic at all. I'm not worried with this. As the test loss has reduced anyway, it means it is moving in the right direction. Okay, it's taking too much time. Why? What is it that happens initially that takes so much time? Does this take this much time? I don't know. Maybe it does. I have no idea. I guess it's just the initialization of the models, but that's already happened. Hmm, this also shouldn't. Oh, yeah. One more thing that I like to check. Stop it. Just stay. Let's see how it goes. There must be some error, some plus one index error here, but I'll resolve it when the time comes. The time asks for it. We must have saved our model too, right? Good. It is moving in the right direction. Great. How much did you have used? 8.8 GB. Yeah, we are not getting anywhere ahead of 10. Reaching 10 even seems like a long shot. Let's just let it train. Let's see if the losses are reducing correctly. And let's wait for this too. If only one iteration happens here, one epoch happens, we have made sure that this is working correctly, and then we can move on. Then we can end this stream peacefully. We just need one iteration here. Just one iteration. Come on. Don't tease me so much. Code is right. The code seems right. I hope you all have understood what I'm doing with all of this and what is the point of layer wise training. And the point of layer wise training would be more clear to you if you will watch the first stream, making a new research paper from scratch. I explained it in a lot more detail there. So I think that would really help in understanding that if you are really interested. Let's just get done with this. Come on, give me one iteration. Why is it taking so much time? Are we gonna crash it again? Don't tell me we are gonna crash it. I hope we are not gonna crash it. Everything seems fine. There is no naming error. I don't know how that naming error causes crashes though. Like, hold it model and optimizer. What kind of recursive loop of initializing models was it stuck into that it exponentially filled the queue? Like I can't make sense of it. I don't know at all. I don't know at all how that worked. Okay, this is still not giving us an iteration. Well, it gave us an iteration after 2.5 minutes previously. Okay, the half minutes have passed already. Wait, that's not a good start. I don't want to crash this. Let's just wait till 5 minutes. After that, we'll have to work something out. Yeah, there shouldn't be though. Maybe initializing the dense layers and stuff is taking longer time because we have more dense layers now. That can be it. Let's see. At least one result should be there. It happened in 3 minutes for that model. I'm assuming having more dense layers will cause longer time initialization, so it would not be too far of it takes 5 to 6 minutes even for the first iteration in this model. Because after that it will be faster, right? Because it just has to go through one convolution layer instead of three. Let's see. Correct. Everywhere. Just like that. I have passed step everywhere I have defined the model, right? All of this is correct. Not doing it using sources. little bit. I think I'll wait. I hope the code made sense though. Code is the important part. There might be a slight bug in here somewhere which is causing this much time. But other than that, makes sense. It should make sense and it's important. It's the only thing that matters anyway. That's what we are trying to learn. Okay, finally worked. Took 5 minutes, 30 seconds to work for the first iteration. Let's see how fast it gets for the second and third ones. Because it should be faster now. That's the idea of it. That makes sense to me. Like it should be faster now because it takes too much time during the initialization phase, but it only has to go through one convolution layer and it just has to iterate through that one layer. So it will be faster in the future iterations, and it will also take less GPU resources, as we can see. Okay, it has taken a little bit GPU resources, but that's just because of the initialization, right? It has to store all the gradients and all the dense layers in the GPU for the first iteration. So that's what took it so much time anyways. So it should be faster now. Let's see. For the first iteration, time did this take? Yeah, but that's because we already did that initialization, right? This is not the this is not something you don't focus on. Still seems faster to me. See the seconds difference, 44, and for one iteration it takes 16 seconds. How much seconds does this take for 628? The last iteration happened. 6. Okay, both of them are taking 16 seconds per iteration. That's interesting. Both of them are taking 16 seconds per iteration. That's cool. Yeah, but I guess the training loop worked fine. We are aware of that now. So that's something we have achieved today. Okay, well, go through the making a research paper from scratch if you want to learn more about how I came up with this code, what is the idea behind it, how did we make sure it works on a basic CIFAR10 data set, all of those interesting stuffs. It is more basic. Like if you're just starting off with deep learning, that should help, I guess. But yeah, I think I should end it here. I'll share the results with you. We'll work on the results together on the stream itself. I'll have to train it on some GPU intensive resources, so I'll have to figure out something. I'll have to arrange some form of GPU for this training part because no, Collab can't handle this. It will take too much time. Collab can't handle this. Like it has already used 10 GB RAM, GPU RAM, and it has only done 3 epochs. We have to go through 500 epochs. Yeah, we need higher GPU. Collab provides us an 8 GB GPU RAM. That's not enough. Maybe we need to go up for 16. I'll try to figure something out. Maybe in the college lab or something, I'll be able to find the GPU. I'll train on the basis of that. And the same thing is gonna go with this. I don't think Collab will be able to train it. Whether it's pretty constant on the 2 GB here there, but I still think I'll need the GPU resources for this too. So yeah, I'm ending the stream here. Hope it helped. Hope you understood everything. If you have any query, let me know in the comments. I'll answer it. Okay. Well, I'll wait for it to train.